Hello everyone. Till now we had studied about many sources of energy and we had learned that how do we utilize those sources to get the energy. Now in this video we are going to learn about the source which is the ultimate source of energy on this earth. This is a source by which a sun gets its energy. We are going to learn about nuclear energy. Now, we started to learn about this energy after Albert Einstein gave its famous equation E equals to mc square. Now, this equation linked the totally unrelated quantities, mass and energy. So, this established a vital link between mass and energy, and it said that mass can be converted into energy and vice versa. That means even energy can be converted into mass. Now there are two processes in which such a conversion is there. That means mass is getting converted into energy. These two processes are nuclear fission and nuclear fusion. So we are going to study first is nuclear fission. As the name indicates, fission is linked with splitting of some bigger thing into some smaller thing. Now, in nuclear fission, a nucleus of a heavy unstable nucleus splits into two lighter and stable nuclei. Now, if we zoom in into the heavier elements like uranium and plutonium, we'll find out that their nuclei is highly unstable. So when a slow moving neutron is bombarded onto these elements, the nucleus absorbs that neutron and then it splits into two lighter nuclei of barium and krypton. Now these two nuclei are stable in nature and a huge amount of energy is released in this process. Since this process involved the breaking of a heavy nucleus into two nuclei, hence it is termed as nuclear fission. Now in this process, where does this energy is coming from? Now if you weigh the two lighter nuclei, you will find out that their weight will be a little smaller than the weight of this heavy nucleus. So we can say that mass which is lost is converted into this huge amount of energy by using Einstein mass energy equivalence, that was E is equals to mc square. Now the energy produced in this process is really huge. 1 gram of uranium-235 produces around 2.5 million times the energy produced by 1 gram of coal while burning. Now to understand this scale, consider that burning of 1 kg coal is represented by this dot. Now if we have to express the energy released by 1 gram of uranium in terms of this dot, our whole screen will be covered by these dots. So we can say that the energy produced by uranium is really huge in comparison to coal or petroleum. The energy from the nuclear reactions can be used in a controlled manner in nuclear reactors to produce steam from water, and then this steam can be used to run the turbines to get electricity. Now the major problem that arises in the use of nuclear reactors is that the waste which is left out after the nuclear reactions is highly poisonous and it also causes cancer. So we have to dispose of this waste in a very far away places from the community. So the disposal of the waste from the nuclear power plant are done in deep sea so as to avoid possible contact with them. But ultimately this waste causes damage to the aquatic life. Also the nuclear power plant should be operated very safely, as a slight error can result in explosion and spread out of the radioactive nuclear waste into the surrounding. The recent nuclear power plant accident took place in Fukushima Daiichi in Japan in April 2011. The good thing about this accident was that the casualties in this accident were minimum. So if we somehow make the nuclear power plant safer and if we somehow find out a way to dispose of their waste, then nuclear energy can power up the world. So this was all about nuclear fission. Let's talk about nuclear fission now. Now this is the process which involves fusion of two lighter nuclei like hydrogen into a heavier nucleus like helium. Now in this process also a small mass is lost and that mass is converted into huge amount of energy. So we can say that in process of fusion also we get a huge amount of energy. There is one problem with fusion. When we try to bring these two nucleus together, they experience a large amount of electrostatic repulsion. And now to overcome that repulsion, we need very high temperatures, the temperatures up to 10 raised to power 6 Kelvin, and those temperatures could not be achieved in controlled manner on Earth. But if we look at the sun, the temperatures are much above this required temperature for fusion. So at sun, this nuclear fusion process takes place. The lighter nuclei of hydrogen combine to form helium and a huge amount of energy is liberated in this process. So the sun receives its energy from nuclear fusion, and this is a huge amount of energy which is generated by nuclear fusion. Only a small amount of this energy from the sun reaches the earth, which sustains the life on this planet.